Perfect, right in time. Good morning, guys, and welcome to this workshop about antennas and artificial intelligence. My name is Jaap, and I'm going to share some experiences with you, having been in this ecosystem and seeing also some people that I've worked with quite a long time ago. My history is a little bit in Sigfox, then a lot in LoRa, and now in the antenna business, so really in the seller of the IoT, but antennas are somewhat critical, specifically on the device side. And I want to share with you my experience, a couple of guidelines and things that we see to try and avoid them, because I completely agree with what Johan and Winke said yesterday. Let's try to focus and collaborate. There are all kinds of pieces that need to glue together, and what I'm seeing here after, I think this is the 5th or the 6th time I'm here in Amsterdam, talking to the TTN world, it's getting more mature. But as you saw, it goes in little steps. There's no hockey stick. So my vision on success is that we need to structure it a little bit better. And I believe when I first did some IoT stuff, well, I said yesterday I even consider SMS IoT, but that is a long time ago. Let's talk IoT stuff when it surfaced in 2010, 2011. The world really was messy. You could buy pieces everywhere and try to glue together your solution. But very rapidly, the companies that raised enormous amounts of money, I myself helped raise 250 million in the Sigfox saga. We understood we have to go to solutions because that's what people want to buy and what people want solutions or want IoT solutions for. And when we had the solutions, then all of a sudden it was about interfaces, and the hyperscalers came in, and some of them disappeared again. But for sure, all these elements need to work together, not just on the software side, but also on the hardware side and on the integration of hardware and software. And last but not least, and I think that's where we are about right now still, is value proposition. You cannot build a $3 pallet tracker. It doesn't exist. So stop doing that. Look at the solution that you need, look at the money that the customer can spend, and see if you can glue it together. If you can bring value that justifies the investment in the device, in the service, in the network. As you saw, it takes thousands of devices. The speaker before me spoke about that for utilities. It takes thousands of gateways, to connect a couple of million endpoints. So are we yet at the stage today that IoT is as simple as Lego? My simple answer is no, we're not. So there's work ahead of us. And if we want to be able to do that, I want to talk a little bit about what we see in our business, because we just make the little tiny antennas in the IoT devices on the edge, and we see a lot of mistakes. So let's see if we can educate you a bit, but more the whole world. Early on in this design stage, you have plenty of options. You choose your radio, your module, your antenna, all the components, battery, all those components. But at that stage, it's kind of easy to change. It doesn't hurt. So at that stage, you should play and try and find the best solution. Through simulation, we do it through AI, and I'll talk about that later, but through choosing your options. Once you start building prototypes, and certainly when those prototypes go into certification, changes just become more painful and more expensive and take more time. And then the answer of the customer is, oh, no, I can't roll it out yet because there's not enough coverage, there's not enough functionality, I need a new feature, whatever it is. I believe that we should be using AI much more in the beginning of the design cycle, finding all these options and then trimming it down into a direction where you don't have to make those mistakes. And we see this every day. This is an example of a module, and there was recently one launched, but I didn't want to blame anybody, so I took a random module. But there was a Semtech launch of an exact module like this with a PCB trace antenna. And there's nothing wrong with a PCB trace. If you take the so-called TI Bible, you will find, 10,000 examples. PCB traces are cheap, and they're kind of easy if you know what you're doing. Unfortunately, most of us, including myself, don't know how to design PCB traces. We don't know how it exactly works. And as a result, it becomes like a darts game. If you want to hit the bullseye, you need to educate yourself and do it right, or hire somebody who knows who can do it right. If you take a chip antenna, not just ours, but any chip antenna, your bullseye becomes unmissable. And let me explain to you why that is. Why even you can use chip antennas better than PCB traces. Because on the left-hand side, you will see in the blue area where that PCB trace will work well. So on the axis, you will see the dimensions of your PCB. You can pick any dimension, right? And then the color kind of indicates if you can have good, what they call TRP, good output power or not. So for the trace antenna, your chance of hitting the bullseye is less than 5%. And this is done with over 38,000 designs that we have done over the years. Right? This is not just some kind of gimmick. This is all simulation data, all devices that were built. We have 50 million antennas in devices live. So this is the reality. So of course, if you choose that PCB and you know what you're doing, fine. Try to hit that bullseye. If you take, however, a chip antenna, which typically costs you a few cents, 20 cents, 30 cents, 40 cents, depending on your supplier, you can see that your hit rate is much more attractive. You have about 50% chance of doing it well. So I'm not preaching for my product, I'm just preaching for LoRa guys, and this applies to cellular or BLE or Wi-Fi also. Be careful with PCB trace antennas, or get somebody involved who knows what he's doing. The next one, what we see in many, many designs, this is a nice symptom. There is a UFL connector somewhere on the board, and you even see them here because they put all these external antennas. But in IoT, people don't like external antennas. So the the UFL connector is put there, such that at the end of the design cycle, you go and find an FPC that fits your design. That's a disaster, because you're pushing the problem till the end. And in the end, you bring in the antenna guy and say, well, it's matched to 50 ohms here, but now you've got to squeeze in this FPC. First of all, in 868 or 915, which are the frequencies we're talking about here, you will find FPCs that are very big. They won't fit in a device. And then people send it to us, and we find these flexible antennas, right? We find them folded into the casing. But of course, that does not work. It doesn't need magic. If you start analyzing how a chip antenna or how an FPC operates, this is a graph, but of course you can get more data online in the report that is also here. You will see that you need a certain distance. I would recommend approximately 40 millimeters. If you have an FPC antenna, then fine. So if you have the space in a smart meter, then fine, you can use it. If you start squeezing it in, if your board is small, don't even consider this. Furthermore, these FPCs are expensive. Right? They have a cable, they have this metal print in the sticker, basically. So it's kind of complex. If you go to a manufacturing plant, you will find a lot of manual insertion for these FPC antennas. Our antennas and any chip antenna is all pick and place, right? So automated. So you can understand that it's more cheap to put it into your product, but it's also, from a quality perspective, much more reliable, because a human being is going to make mistakes, and the cable is going to be somewhere where it doesn't need to be. And at the end, the range of your device, the range of the LoRa device, is not what it should be. The second element that we see a lot is the so-called VSWR or S11. For those of you who are not antenna engineers like myself, it's very simple. The industry settled on a certain way of 50 ohms. That is the value that needs to be there in the chain between the module and the antenna. But at the end, some of that energy gets reflected. And the more reflection you have, let's say just for discussion's sake, 50%, you understand that the energy that you take out of the battery through the module to the antenna, if you reflect 50%, basically you lose half of the energy, which is a pity. So you, as a designer or as a customer, should ask for devices that have 99% throughput of that energy, because that's what creates the range. Now, the trick that people do is they put more power on the battery side that you initially put in, because if you lack 50% in the throughput, then let's put 50% more power into the module, and then at the end you will compensate. But you can guess the end result, right? It's quite linear. If you use 50% more power, the lifespan of your battery is going to be half. So same thing, measure all this. You can do it yourself. It requires VNA, which is a couple of €1,000. And if not, send it to somebody who knows how to measure it. And they'll tell you these values. And you can ask the intelligent questions now, which are basically the main drivers to get range out of your LoRa device and to get battery life extended. What I've seen is that we need to simplify further. Back to my Lego story. When I came into this antenna company from the Semtech and LoRa world, I found out that it was too complex. So what we built is a cloud environment that you can go to. It's free of charge. You can put in your design, and it'll tell you exactly which antenna to use. So no more need to go to DigiKey or Mouser and be flabbergasted by 1,200 options. Just go there and select, the cloud will select your solution. You get the design recommendations, exactly how to do this, and then you can build your device. And examples are here because the Things Networks generic node is built with this concept. The beauty is that if you follow this path, you will get 95% accuracy in the end product. And the reason why is that we do our 3,000 designs this year, we always put the end values that are achieved in the real device back into the AI model so that the algorithms learn how good their advice was in the first place. Now, I have a request for you, because the AI world that we have built, the algorithms that we've built are ready. There's going to be an interface. It's not going to look exactly like this, but it's going to be something like this. And in that interface, you can even play. You can put the antenna on the board where you want. You can play with the so-called clearance area. How much space do you really have? You can play with the feeding line, all a bit technical. But people who want to try and do this, they have the ability to do so. So that interface must be tuned to what non-RF engineers can understand. And that's a bit difficult for a company as ours, because I have all 50 RF engineers. So I'm reaching out for your help to contact us and let us know, because we're looking for beta testers in the October timeframe to help us look at this and tell us your feedback. It's free of charge anyway, but it can also help you in getting, let's say, more suggestions of how to design your devices. So I believe that with these tools and with the products, the chip antennas that are available, we can make it better. And we've proven so. You'll find on the wall of fame and in several demos this little red part that we are using. But don't get me wrong, any chip antenna is probably good. It's just that ours is a little bit more flexible, and we make it more accessible to people who don't understand what they call the black magic. I believe that if we make it more simple and more reliable, we can also go faster. Because one of the comments that I hear on the floor, and last night in the bar even more, is it takes forever. We can't get out of this mode. I want to scale. And I can tell you, I have customers, the biggest deployment we have is 30 million cases. So 30 million devices. It's unfortunately not on LoRa, but it doesn't really matter. It's about an IoT solution that starts scaling. So if you follow a path and you make it simple internal and simple for your customer, I truly believe we can get this market to a much better penetration than where we are at today. Thank you very much for your attention. If you want to see this in the real world and put your hands on, or you want to play a little bit with it, there's a workshop this afternoon at 4 o'clock by one of our engineers. I don't know exactly where, but you'll find your way. And there basically you can see this and test it for yourself. Thank you very much for your attention, and if there's any questions, I'll be available here to talk to you. Thanks.